What's up, everybody? Good morning. So, it's been a second since I've streamed. Part of that is due to it's just holidays, so work's kind of crazy because we're trying to wrap up projects before we all take break. I'm doing vacation stuff with family for Christmas, all that kind of stuff. So it's difficult to keep consistent with this type of stuff. But that doesn't mean I haven't been working on it. So what I've been doing is I've been wanting to do this for a while, trying to figure out a good way to do it, but I finally did, and I'm fairly happy with it, is to turn Gunslinger into a header-only game framework. Hey, Pistolify. So I've gotten a lot of comments about people that download Gunslinger, and while the build process I think is fairly straightforward, and I think most people do, I still get one or two people, probably every couple of weeks or so, that have issues building. So what I'm going to do is completely get around that, and it's just going to be header only. So that is a couple of caveats. One of those being that there is a possibility that build times could increase. However, I have not seen it. I have an example here, which I'll go through here in a second, that I've been using to go through all the features as I add them. And the build times on release for Windows are under 3 seconds. And that's including rebuilding the entire Gunslinger framework every single time that I rebuild the project. Of course, if that becomes an issue in the future, what you could do is you could actually build this out to a static library and then just include it the way you were doing before. I'm not going to go over this too much right now because there's a lot in it. Several thousand lines of code, and this is just the main interface file. There's also implementation files for audio. There's graphics, and then there's a platform layer as well. So what I'm going to do is today I'm working more on the graphics implementation. What I've done is I've stripped away a lot of the graphics interface that was before. Let me go to, where's the graphics interface? Oh, it's in here. Yeah, so this is now the graphics interface. If I actually pull up what it used to be, it was, let's see, where the hell is it? Already passed it? Yeah, it's this guy. I was passing it up. So it was this. It was a huge interface, had all these function pointers in it. The benefit of this was that during runtime, you could set these to whatever you wanted. I'm starting to realize that that's probably not as useful as I thought it was before. So what I've done instead is I've stripped this all out. I've made the interface simpler. Right now, the entire interface for the graphics, audio, whatever, they're actual interfaces. And then the API itself is stripped out, and then that can be defined by the user, whatever they want it to be. And the API has gotten much simpler. This is the entire graphics API. This is all it will be, most likely. Maybe a couple more update functions here, but this is pretty much it. So everything is done in an explicit style, similar to the way that you would do like Vulkan or DX12. And that's going to work for OpenGL. That's going to work for OpenGL. I also have plans to write a software renderer in the future, but it'll still use like a custom shader language to evaluate all that stuff. I was thinking about it yesterday. It sounded like it'd be fun to do. And it'd be fun to actually do a stream on how to write a software renderer for people that are interested. But yeah, this is the entire graphics API, and that's, like I said, it's all it's going to be. And this handles everything because it's done in an explicit way. So what I need to work on now is continuing this. So this is, again, the sample implementation I've been working on. if you're familiar with Vulkan, this should look fairly similar. So what you do in, let's go over like what the resources are for graphics. You have 5 main resources. That's your, let's see, I haven't defined. No, I don't. Anyway, your 5 main resources, yeah, here they are. So it's a shader, you have a texture object, you have a buffer object, you have a pipeline object, and you have a render pass object. That's it. Those are the 5. Hey Shankar, does C89 support Unicode? Actually, I'm not sure. That's a good question. I don't believe so. It might depend on compiler. Yeah, it's implementation defined, so totally up to the compiler. C99 might, however, and that's what I use. So, if that answers your question. Get back to my chat. GLDev, what does it mean to be header only? That means you do not have to compile the library separately. You could just drop it into your code and use it. So if you've ever used any header only libraries, typically the way it works is that you have an interface file, and what you do is you have other header files that define an implementation, right? So C code is interesting. You can name your C file whatever you wanted, right? Glad you pinged us on Discord. Yeah, man. I'm usually pretty shy about doing that because I'm annoyed when, or I think people get annoyed whenever they're doing it. I thought maybe you could write graphics in the console using Unicode. C++ you can. C99 I'm fairly sure you can. Don't take my word on it. I haven't done it, but I'm pretty sure you can. So, what does it mean to be header only? It means you don't have to compile it separately. So let's look at this example project here, okay? So imagine this is your project, right? If we look at the actual compile instructions for this, nowhere in here am I compiling the Gunslinger library. All it's doing is just including it and then defining those implementations. So if we look at this, right before I include the Gunslinger library, it defines this GSMPL. This is the Gunslinger implementation, and what that does, as it's defined here, is that it goes through and it actually defines all the implementation stuff. So at the very beginning of all of this is all interface stuff, and then we have this API declaration. That means that these are all going to be externed and defined somewhere else. And then if we come down below all of this, below the interface, there's an actual implementation area. So you have to define this, and what it does is that it just defines it in the one translation unit that this gets included in, right? So it'll define it once, come through here and actually define all these functions. And then for all of the other interfaces, right, so all the other subsystems like platform, graphics, audio, stuff like that, all of these then get defined, which these are going to be ripped out. These are going to be put inside of a config file, so you can define your own interfaces if you want, or your own implementation for the interfaces. So if we look at graphics, that's what I'm doing right now. So we're going to define the graphics implementation to be OpenGL, at least for now. Like I said, this is going to be ripped out in the future. And if we go to the graphics implementation, we have its own implementation defines here. So only if this graphics implementation is defined will it start to define all this stuff. And notice here is all OpenGL specific stuff. And this is where the actual OpenGL implementation for the graphics API gets done. And what this allows me to do, like I said, is that I don't have to compile this library separately like you would for most third-party libraries that you pull down. It's just whatever. How do you get Sublime Text to recognize libraries? It doesn't. Yeah, it's just my own build system. Just use bats. I just use bat files. So when I started out programming, I used bat files, and then thought I was too cool for that, and then moved on to Visual Studio, and then moved on to CMake because I thought that was the best, and that's what I used for my last game engine. And now I'm back to bat files because they're simple, and I like simple. And ironically enough, this supports more than my last one did with CMake. So right out of the bat. So I have CL, I also support MinGW, OSX supporting GCC. You can also write Clang for this, and then Linux can do Clang or GCC. Right. Simple. So yeah, so let's go back. But like I said, so the entire process of this is just including it and then defining that implementation. Much like if you guys use like the STB libraries or any other header-only libraries, they're kind of becoming more and more popular, which I like. It just makes building for C and C++ that much easier. It's really a pain in the ass. So do you get auto-completion for the library in Sublime? No, not really. I just keep it all in my head, honestly. How would you have a simple OpenGL program run on Sublime? I think you're getting mixed up. Sublime's just a text editor, man. It's not an IDE. So how do I get a simple OpenGL program going? Well, you need a platform layer in order to define your OpenGL context, and then you need to set everything up. Like if we look at the actual platform layer, the platform layer by default is using GLFW, by the way. So it just includes it and compiles it along with the rest of the library. But it's all header only. So if we look at the platform layer, so platform init. So for GLFW, just initialize GLFW. Depending on what the implementation is platform-wise, it'll do certain things. Right now, this is all just kind of stock put in there. It's going to be abstracted away. And then that's it. Creates your window context. Whenever you create a window, down here creating the window and all this context stuff. But again, we could not define implementation GLFW. So whenever we go into gs.h, get rid of this, and instead have your own implementation. Like if you wanted a Win32 implementation and then write it yourself, you could do that, right? Or if you wanted an Android implementation, then write your own. That's the future that I'm headed towards, right? But again, this won't be in here. Instead, there's going to be like a gsconfig.h, and inside of it is going to have, or maybe it's like user config, and it'll have all of the defines that you can do, right? So define GS platform implementation, you know, whatever you want to do, right? And so by default, it's going to have this GLFW. But if you want to get rid of it, then just do whatever. Or what it could have instead is by default, I do this. And then at the top, I'll include that. And then what I'll say is like, if define GS user platform custom, I don't know, something like that. Then I'll undefine this. And then yours will be defined whatever you want. Does that make sense? So you define this custom one, whatever you want it to be, and then it gets included, and yeah, so. But yeah, that's how this is gonna work in the future. Hey, Saeed. So hopefully that kind of goes over where I'm headed and the philosophy behind this. What I'm gonna plan on doing, guys, is once I get all this done, this is just streaming, me developing this shit. Once I actually get it going, then I'm gonna make a video going over how to use it and make a simple project. And I've already written Pong using Gunslinger, so I'll probably just go over that and show the two different ways to do it. So what I'm gonna do is for the immediate mode stuff, I'm gonna rewrite that using this new pipeline system. And what I'll do is write it in the two different ways. So one using the explicit approach, and then one using the immediate approach. And then, yeah. I think that'll give a good introduction to what this library is capable of and how you can use it. And I think people will be interested in using it, honestly. Because the way I've written things to be set up, I could very easily start including more explicit libraries in the back end, including Vulkan, DX12, and Metal. So, which is where I'd like to go. So roadmap is get mobile support, get Raspberry Pi support, get web support, and then have explicit libraries in the back end. So that is the headline, or the direction I'm heading. Do you recommend me to wait till the header only release? Yeah, I do. Definitely. Can you make a video on how to set up Sublime for C++ and OpenGL development? Yeah, I'll do that in the video. Let me make a note of that, because really I don't use it to build, so I don't use it to run scripts or anything. I just pull up the command line. But you can make scripts. So this is how I compile. But you can make scripts to do this. So maybe I'll try to make a couple and then make a video talking about it. So really all I don't have any, see, it doesn't even do this for me. Dude, I love you. Yeah, dude, I just build from the command line. That's it. Mobile support, I'll be happy. Yeah, and it's going to be a hands-off thing. So the idea behind all this stuff is to be a light wrapper around all of the OS specific stuff. Like the minimal amount, to me this is what a good library is. It's the minimal amount provided to you in order to handle all of the boilerplate bullshit that you don't want to deal with, right? So there are a few of my own abstractions here, right? Like this GS handle. I do have to keep track of internal resources, but it's very minimal, right? A lot of this stuff is fairly explicit and mandatory. So if we go into here, this is, like, I'll pull up what this actually does. This is the app that it's actually running, right? So it's a quad, it's got a texture bound to it, and then it's like stretching over time, right? So it's stretching, rotating, and translating over time. So I'm updating a model matrix, and I'm pushing that as a uniform. I'm pushing a sampler in order to sample the texture. Yeah, so this is what this is doing, right? Very simple application, but still it's got a little bit involved with it, right? It's not so simple as, you know, I love Raylib, but Raylib is designed to be a beginner's introduction into graphics, right? And it's fantastic for that. I recommend anyone that has not used any graphics programming before and is completely new to it, go for it. Use Raylib because it gets you introduced into the concepts. The only problem is it's not low level enough, right? So if you want to define like custom pipelines and you want to do stuff like that, it's very, I think you can do it. I haven't used it enough. I think you can do it, but it's too hands-on. It's not granular enough. With this, you have to be very explicit about what you're setting up, right? You have to set up your vertex data. You have to set up your index data. You have to set up your pipeline, your uniforms. You have to create buffers. You have to do all that stuff. So it's just a step above having to do all the bullshit of like doing direct OpenGL calls. And really the main reason for doing this is I want the platform to be platform independent, and I want the graphics API to be graphics API independent. That's it. Anyway, let's see. Would you like to make an editor for GS, or will it just be a library? So the core of GS is just going to be a framework, right? Because I started this whole framework for stuff that I needed to do for work, right? I needed an easy way to make tools, and having an editor for that really wouldn't do much for me. So that being said, I would like to have, so this is what I'm going to do for the immediate mode stuff. In the old implementation of Gunslinger, and I say old, I mean like a week ago. If we look at graphics.h, so we had this immediate mode draw interface, right? This huge monstrous fucking thing, and then it was included inside of the graphics interface, right? Totally cache friendly. So where is it? You're right here. So it includes an instance of this immediate mode, right? And so then what you would do is if you wanted to render anything with it, which I have an example, you would do this stuff, right? And I did a video covering this, right? I think we did this exact same thing in a previous stream. So you would reach into that interface and you would start doing all this stuff. This isn't going to be the way it works. Again, like I said, in the new interface, this is the entire API. It's not going to grow, right? It's gonna stay more or less like this. Maybe a few more updates in here, and these actually might go away. These might have to be command buffer. You might have to request updates, and you can't do them directly. But it won't grow past this, right? So what I'm going to do instead is, if we look at the actual library, which this is what Gunslinger is going to be released as. It's going to have an external folder to have all the third-party stuff that Gunslinger relies on. Again, all header only. Then it's going to have implementation files for the Gunslinger library, and then it'll have the main interface file. What I'll probably have is something like a util folder, and inside of that is going to have stuff that you can include. You don't have to. So what you could do is define like GS immediate draw implementation, something like that, and then include this. And then what it'll do is it'll look into that util and it'll grab the immediate mode implementation and it'll do that, right? So you probably have to include like GS util immediate, something like that. And then you'll be able to do stuff like GS immediate draw triangle, something like that. And it's going to handle all this stuff in the back end for you, but it's not part of the core framework, so you don't have to use it, right? So it slims stuff down, you can get rid of it and release stuff. Yeah, and then I can put a lot of cool utils in there. So what we could do is actually have like a game engine util, probably stuff that's more application specific, like defining what a material is. That's totally application specific. What I consider to be a material is totally different from you, right? They're not graphics resources. Same thing with meshes, same thing with all that stuff. So, thanks, Saeed. Appreciate it, man. My goal with this channel is really to make this as robust and easy to use a library as possible, and continue to work on it full time. That's kind of where I'd like to get. So I'd like to do tutorials around it. I'd like to do basic OpenGL tutorials as well. People keep asking me for stuff. People keep asking me for doing OpenGL tutorials, or they always ask me, you know, where do you go for OpenGL? It's like, I should just make it so I can just stop giving other people the traffic. All right, so I think I've described this enough. Let me see if I'm missing anything. Is it okay to learn an old version of OGL? Yeah, I think so. 3.3 is standard, anything above, so that's considered core. So learn that definitely first. But if you want to do immediate mode stuff, actually I think immediate mode's fine. Totally. It depends on what you want it for, right? Immediate mode's good because it forces you to kind of understand the pipeline a little bit, I think. Have you studied assembly? Sure, yeah. I like assembly. I'll probably get a wild hair in my ass and do a assembly engine someday. but for now, C is good. I don't think I'd get any traction if I did an assembly engine. I don't think people would want it. So I think C is probably as low as I can go. All right, so let's work. Enough talk, more work. Like I said, this is kind of where we are. What I need to finish is some pipeline stuff. So if I go to the graphics implementation, where we actually bind a pipeline. So we go to bind pipeline. Oh yeah, so the opcodes, by the way. So if you've watched the previous streams where I talk about the command buffer and the VM that kind of runs in the graphics subsystem, let me pull that up for comparison, like just to show you how much simpler this has gotten. So the opcodes, right? So here's where the opcodes used to be. It's probably like 25, 30 ops. Here's what they are now. It's 1, 2, 3, 4, 5, 6, 7, so 8 opcodes, right? And this doesn't really need to change past this. This is all that this is going to be. This maybe might go away. Maybe this is a little too explicit, but this is available in explicit frameworks. So you can directly set a viewport, directly set a view scissor in Vulkan. So I might keep it just because it's still possible to do that in Vulkan. So I don't have to like go from an implicit framework to an explicit framework. That would be tough to do. That's why I've written this as an explicit framework so that it's easy to do the other way around. So let's do bind pipeline. So when you bind a pipeline, you pass in a handle to your pipeline. We're going to push that pipeline back. When you create a pipeline, so a pipeline, this is for people that aren't familiar with explicit languages. If we go to what a pipeline description is, it has different states that describe what's going to happen for your rendering. Okay, so it has a blend state description, has a depth state description, raster, stencil, and then it has a vertex layout, and then the size of the vertex layout. Is that right? Size and bytes of the vertex to byte. Yeah. So for the raster state, it's your face culling, your winding order, primitives, so what you're going to be drawing in, whether it's going to be lines, quads, whatever else, a shader to bind for this pipeline, and then if you have an index buffer bound, what the actual size of the index buffer is going to be, so that you can pass that to the GPU in order to know how to iterate through the data. Let's see, depth state, so all your depth state stuff, your function or stencil state, all the functions that you would typically expect to have, all the parameters, same with the depth state, blend state, how you want to set up the blending, and that's it. So when you go to create a pipeline, what you do is you pass in that description, creates a new pipeline in the back end, sets all that stuff. It sets the layout that you have. So the layout is your vertex attribute. So vertex attribute type, you just pass this in as an array. So if we go up here, we look at this, we have a layout where we have a vec2 for a position, a vec2 for a UV. And then when we go to define the layout down here, we pass in that we're going to do a float2 for position, float2 for UV, and we set that in our pipeline. Okay. So pipeline create, back down here, push in our layout, and then we, in the graphics implementation, we have a slot array. Slot array is used for being able to hold references to an array that moves. So the problem with dynamic arrays is that you can't hold pointers to positions in the array because you're going to reallocate the memory and then it's going to move and you're going to lose that pointer reference. So what you do instead is you give an opaque handle back, which is just a uint32. And that allows you to be able to dereference into the array. So creating the pipeline, returning back a handle, and there you go. Now whenever we bind our pipeline, so where's that? Bind a pipeline. So all we're doing is writing in the handle ID. Easy enough, right? Into our command buffer. And then when we actually submit the command buffer, again, this is covered in a previous stream, kind of how this works, but it's just a virtual machine. So each of the commands is an opcode and then a data packet. So we read through all the commands that's in the buffer, read our first opcode, and then we go to bind pipeline. This is what I need to start filling out. So I have some of this stuff done already. So the depth is done, the stencil is done, but now I need to do the blend states and the raster states, and then I finish up the pipeline. So that's what I'm working on now. So, and they are a chore to fill out, so. Let's see. It draws on the window. Cool, that sounds like a, there's a, I'm reading your stuff, Saeed. There's a, well, a software rendering OpenGL library out there. It's pretty cool. I'd like to read through it. But yeah, it doesn't use any hardware acceleration. It's all software rendered, but it uses OpenGL commands as its interface. So you can write it like OpenGL code, and it'll do the software rendering in the back end for you. That's what I want to write for this, by the way. I want to write an implementation for the graphics in the platform that's software rendered. So you could do something that doesn't have hardware acceleration. You could still kind of treat it like that. It's just going to be slow as shit. But, you know, you could do simple stuff with it. Alrighty, blend states. So let me start going. So if we look at pipeline, the blend description. So we need to grab this stuff from our pipeline. So I have a blend equation, source and destination. I might have to pull up, let's see, and look at my previous implementation. I always forget this stuff. So, what is it called? It's like blend equation, set blend equation. I'm gonna need to do this. GS blend equation type. What do I have? What's the defaults? I've not decided on a default. What is default blend equation for Opengl blend equation? What's our default? Blend equation I, blend equation, blend equation source, blend equation I. What is the default? Does it not say the default? I think initially, initially both are RGB blend equation and alpha blend are set to GL func add. GL blend equation I specifies blend equation for single draw buffer. Okay, so I'm gonna have to support this for multiple render targets. Is this an extension? Blend equation I. For now, I'm not gonna support it, but I'm gonna have to. Fun. Oh, blend equation I is only supported at 4, so I might make a 4.1 restriction for OpenGL, because that is where Mac stopped. I want OpenGL still supported on Mac. All the core is going to be implemented. Man. Okay. Blend equation, enum mode. All right. So default is func add, which is the top one I have there. Oh God me. I have the worst memory, I swear. Switch on our type, and we'll pull these, and the default is this. Okay, case. Shit. Okay. So we're gonna do, the equation is GL func add. Func equation min. Oh, just min. All right. Cool. Func min is undeclared. Is it? Is it though? GL min, okay. Those consistent naming conventions for OpenGL. By the way, do you guys see how fast this compiles? Let me do it again. That's, yeah, what, a second? That's for everything. And that's including all the libraries as headers. And let me just make this consistent. Where did my music go? Yes. God, YouTube's annoying. Okay, so we've got the blend equation. Let me copy this. we need to check to see if it's enabled, because I think you do GL blend, right? So you enable that. So if we don't have a function, so let's see. Should probably just call this func. So we'll disable the blend. Otherwise, we're going to enable it. And we're going to have to grab the function. So GL blend equation. And we'll set it like that. Let me go ahead and change this. I like this being consistent, so we'll call that func. Okay. So compile. Unresolved GS, yeah. I'm pretty sure that's how you do that. Let me verify. Come on. So there's a GL enable. Where you at? GL blend func. So we're going to do for GL get GL blend func. Okay. OpenGL enable blend. It should be enabled GL blend. Yep. Okay. Alrighty, so that should be good. Now we need to write a function in order to do the blend source. Let me pull this up. So blend func, yeah, so we'll get our blend functions. Where we grab the source function and then we grab the alpha function, okay? Blend mode to GL, blend mode, pipe, blend, let's just call that source. Still waiting for the Gameslinger jam, the Gunslinger jam. Yep, you'll get it. This is all in direction towards that. So the issue with doing the GS jam is that I really want to have model loading and maybe, I don't know, I'd like to have 3D animations in there. So I don't know. I think majority of people are going to want something like that. And if I don't have it, I'm just going to piss people off. So I'm probably going to do at least a GLTF loader and then support some kind of 3D animations. So you could do simple stuff. I don't know. You guys let me know. If not, then we could not have it and we could do it sooner. I'd like to get a feel for what like the min spec should be for the jam. But at bare minimum, it'll have immediate mode and some simple shapes. But I don't think that's going to be enough for people. I could be wrong. I don't think I am. Graphics, blend mode type. What's my defaults? Blend funk. And the default is 0, 1. Perfect. So these are different. All right, let's do, I hate that, but fuck it. Let's do that. I thought we were going for the 2D jam first. We could do that. Let's do we could do a 2D jam. That'd be fine. I just know, I don't know if Guillermo is it still in here? It's a unit A. But he wants model loading, so he could do 3D model stuff. And I'd like to have him included, so. Hey, Peace Games, welcome. Graphics blend mode type. That's not really working. I'll just do this. It's Opengl specific, but that's fine. All right, switch on our type. And again, if we go to blend mode type. And we will not have a default for this because we're going to set it there. We should turn our mode. So I tried both SDL and OGL. I mean GLFW. So you used, okay. Cool. Which one did you like more? Okay. Cool. Okay. Where is thank you? Holy. Graphics blend mode disabled. Get rid of that. Get rid of that. GL source alpha. So yeah, this is all just drudge work. Just turn off your brain and just go, unfortunately. Or maybe not, I don't know. If I have to stream and talk, it's unfortunate. That's the only thing. GL constant color, GL1 minus. Okay, GL minus constant color, GL, is there a saturate? Why do I have that there? Alpha saturate? Why do I have that there? Blend funk I, okay. I think some of these are, let's see. Alpha saturate, S factor. I think these are I'm not sure about this. For now, I won't include it. And we'll get rid of it here. Just because I'm not entirely sure if that's a... if that's specific to... That might be specific to setting up the individual channels, which I'll do eventually. Alright, so let's get rid of this. GSGL blend mode. So we set up our blend function. We need to pass in defaults for these. I need to look and see what those were. Default for the source is GL1. And default for the destination is GL0. Okay. What am I missing? 154. What's the problem, bro? Because it's called default. Yep. 166. Okay. Yeah, if I were doing a beginner graphics stream, we wouldn't be writing this. Not at all. This is a little too much. Again, this is setting up a VM in the back end in order to be able to do taking non-API specific interface and mapping that down to an API specific interface. That's not where you start out at all. Okay. I should just start doing OpenGL tutorials, get to Cherno status. I'm just not going to show my face and wave my arms. If you guys are cool with that. All right, so back to our pipeline. So we bind our blend state. That is everything. Easy. So now the rasterizer. So so let me look at the face culling. So if not, pipeline raster dot face culling. So this will be disabled. I like Cherno, but I don't like to be constrained to Windows. Yep, and this is definitely not constrained to that. I do development on this in the evenings on my Mac. In the mornings, I stream and do development on here in the Windows. And then I need a Linux machine, man. I don't have one. Using the VM for that sucks. I need a dedicated Linux laptop. Maybe Santa will bring me one. And again, like I said, I want Raspberry Pi support because I want to make, I do hardware stuff, like just around the house. I like doing automation and shit. So it'd be cool to be able to write my own like Raspberry Pi GUI for, you know, various stuff. It'd also be cool to have like a, with all these interfaces or the implementations, if you make dummy implementations, the library gets really small. So I could actually use this for like Arduino. So we could do that as well. But if I strip out GLFW implementation, if I strip out OpenGL, you just have the interface. It's just like whatever. x86 Shankar, GLDev. Can't you ask in your job to give you a Linux one, or are you doing iOS stuff? No, we do Android stuff. we do Android stuff, and we use Macs because our designers are ridiculous, and so they made that requirement. My software division for my job came on after the fact. So it's a fashion company that got into doing smartwatches. And before that, you know, all the designers, they're designers and artists, and they like Macs, right? At least non-game specific artists and designers. Game specific or like graphics specific artists and designers, they all use Windows machines. Or Linux maybe, but mostly they use, I would be surprised if they use Linux. It's mainly Windows machines from my experience. But other designers, they just like Macs. I don't get it. I don't understand it. So GL enable, GL disable. So GL enable cull face, and then we need to look for the winding order type, which I think there's a cull face function. GL cull face culling. GL cull face, and we'll get the oh yeah, so you can set the front face to be that. I probably won't. I won't specify that. That's just the granularity is not it's not needed. So we'll just do GL cull face, GSGL cull face to GL cull face pipe raster face culling. So the largest part of this implementation is just doing the conversions of a lot of these enums. I'm sure there's a better way to, or at least a way to make this smaller, but I do like how explicit it is, and I think it's easier to read, so you can just go through this and you're like, okay, I see what you're doing. You're taking what's the default? I need to find the default. You're just taking this and running with it. So Face calling. No, give me the actual reference. Thank you. So GL back is the default, right? Switch on the type. Oh, Windows 10 is garbage. I agree. iOS sucks. I hate it with a passion. I agree. Did y'all see was it Windows 10 recently had like a lot of security issues? Like an update went out that shouldn't, and like I can't remember. I just thought it was funny. iOS sucks. Hate it with a passion. Agreed. Hate modern UI design. Agreed. Everything these days is abstraction over abstraction. Yeah, I want to make a video about that, actually. I think that video will piss people off, but I want to make a video about it. GS graphics. Face call. Back. Let me go face call and type and make sure. No. Gorgeous. Cool. Oh. Win 10 Linux and Mac OS are all garbage based. Let's see. What's the effective, fun way to learn x86? I don't know. I took it in a college course. That wasn't fun. So... The professor's notes were written. The professor was an adjunct. That's why I think college is a waste of time. So the professor was an adjunct. He was a physics professor that also taught assembly for some reason. And his course notes were stolen from somebody else. They're credited and used to someone else. He didn't write himself, right? Didn't have time. He's an adjunct, obviously. So he has all these course notes, which are written for ARM, and then all of the program assignments, which he didn't write himself, were all in assembly. So that was fun for students who didn't know what the hell was going on and were totally confused, and it was their first time learning computer architecture and assembly language, because they're learning two different architectures. Totally confusing. So don't learn it that way. Okay, so we got calling face. Let me go ahead and just mark these. Ditch 86. Abandon x86. Abandon modernity. Stencil funk. Depth funk. Yeah, whatever. No. It's just too much. Too much. Face calling. Set winding order. I don't think winding order you don't really call anything with that. The wiki's huge. Oh, no, it's useless. Geo front face, geo cull face. You're not going to give me anything for winding order, are you? Desolation winding order. Oh, come on. It's useless. What'd someone say? Doc.gl? I don't think I've really ever used that. Nope. Oh, just look at my own shit. I wanted to be a good programmer and look at where is it? So you set the front face to be that. Okay, set the winding order. I'll just call this winding order. We're already setting the primitive. Right? I'm setting that. Where am I setting that? See, I should be setting that in here. So raster dot, but I'm not. So where is that getting set? Oh, because it's default. By default, I call geotriangles. Right. So I get the primitive type down here, and then I set it. Okay. All right, I don't have to worry about that. Cool. And then the shader I don't have to worry about. So it's really just these. So this is the last bit. Super duper. So the winding order, I do need to create that. Just blend mode. Face call depth. Winding order equals GL CCW, correct? Default is CCW. Okay. Case GS graphics. Let's see, what's up with Contra? Contra is in a weird state right now. So I started doing some immediate mode stuff because I needed it for Contra. And then, like anything else, I get sidetracked with what I actually wanted to be working on, which was the game engine. I'm an engine developer. So I plan on finishing it. I'm just putting it on kind of hold for now, because what I want to do instead is finish up this framework, or at least the implementation of this framework, to have a release, then do a video about it, show demonstration on how to use it, the philosophy behind it, make it nice, have animations and all that shit like I used to do, and then announce a game jam with it. That's the plan. So I hope that's okay. It should be good. Okay. Because if you've missed it, if you just joined, Brute Rasta, good name. I've been turning the framework into a header-only library. So I'd like to finish that up. So I think the pipeline's done. So let me look. So we have depth state, stencil state, blend state, raster state. Bind the shader. And that's good. This is all in a private repo right now, by the way. Just a dev repo. Eventually, at the end of this, I'm going to switch over the Gunslinger repo to all of this. So this will be available. Just while it's in process, I'm updating stuff and it's broken and I don't want people pulling. So there's a few more things that really need to be added to this, like binding frame buffers, MRT, color attachments, depth attachments, stuff like that. So I need to start working on that. But this really shouldn't grow too much more. So OpenGL implementation, a full OpenGL backend implementation. It's about 1,000 lines of code. So that's with a VM. Not bad. I'll be right back. I'm gonna get some more coffee. All right, I'm back. Okay. All right. So we got that going. What should we work on now? Probably render passes. Those need to be worked on. So the way render passes work is pretty much the exact same way you do it in Vulkan. Is you define a render pass description and it has all your color attachments, your frame buffer you want to use, what else? Depth attachment, and then you pass in action flags for what you want to happen to those render attachments, right? So clear color with a color that you want, clear depth, clear stencil, values for that. So I'm going to have to fill out a couple things. So like this, these I need to have more in here. Fairly limited right now, so I need at least like a 32F as well. If you wanted to have 32, I need to have depth, normal, like all that kind of stuff. Well, not normal, that's just gonna be defined in this, but like RG8, RG32, RG16. There's so many texture formats, so I'm gonna have to support those. Okay. And it's all just drudge work. It's all just God. So this is going to be a pain in the ass. Expect a lot of crashes here. Wouldn't Contra, even a small portion, be a good engine demo? You'd see what works and what's not. Yeah, the issue is the scope, right? So at some point you get past what the engine's capable of doing, and all you're doing is you're just making a game. Right? Like me writing a AI implementation, me making a scene, me doing all that stuff, it's not really showing you what's capable with the framework. It's showing you what I'm capable of doing in terms of making a game, which really isn't the point. I think doing something more directed and specific, like Pong, if it had like not just simple Pong, right? But let's say that we had like post-processing effects, right? We wanted to like screen warp so it looks like it's on a CRT monitor. We wanted to do like the scan lines to make it look like that. Adding sound effects, right? I mean, that's a full game. It has a full game implementation, right? It has rules, it has a game state, it has winning conditions and losing conditions, etc. And it'll do all of the stuff that you should be able to do with the engine. Load sound, load textures, load fonts, display all that stuff, draw it, implementing custom vertex buffers and index buffers and all that shit, custom shaders. If you're going to do post-processing, you're binding frame buffers with render targets, and you're doing all of that. Like that's a full 2D pipeline. And it wouldn't take as long. That's the thing. I want to put stuff out more consistently. And the problem I have with Contra, I like the idea. It just takes so fucking long. That's the problem. Can you talk again about using an older version of Opengl? There are many great old graphics books in my drive. What do you want to know about it? All right, let's get going. We have to make a frame buffer, set attachments. I don't think you can have multiple depth attachments. I don't think that's a thing, either in Vulkan or... Yeah, it doesn't mean I won't finish it. I just think moving on to this is more interesting to more people. Again, there are a lot of people that are interested in doing the game jam, so I wanted to get to that point, right? Let's see. Some say like learning old GL versions first. Some say stick to modern. I'd say learn modern first, and then get familiar with that pipeline. Use it for a bit. Get comfortable with it, and then learn old versions. That's what I'd say. Like I've never really used immediate mode for anything, but I'm gonna write an immediate mode version that sits on top of my graphics implementation, right? That's gonna mirror. It's gonna mirror how immediate works, but it's useful for doing like immediate mode GUI and stuff like that, or doing a quad batch implementation, you know, all that kind of stuff. Frame buffer. Next we have stencil. We have depth. We have color, depth. And then it can be a read buffer. Yeah, Vulkan's got a lot. It's got quite a bit. Vulkan is what happens when you take away any abstraction and you get as much granularity as possible, which is good, but overwhelming. Color attachment I, depth attachment, stencil. So how do I want this to work? So when you need to have like what am I expecting here? If you want to write to a color attachment, you have to have a frame buffer attached that isn't the back buffer, right? You can't attach a color buffer to the back buffer. If you want to do this, you have to have a frame buffer. So let's look at this. You gotta have a frame buffer, which is basically just it's a modern OpenGL concept, but you have to use it as a wrapper in order to point to the memory for the render targets. That's kind of how that works. It's like vertex array buffers for vertex buffers. Yeah, I think 2.1 is when the programmable pipeline started. I think you're right about that. Which is what shaders are. So we're going to bind our frame buffer. We're already going to generate our render texture. I don't really care about that. Texture. Which this is already implemented. We just have color textures. We can already do that. Let's see. And a depth buffer is optional. You don't need it, but we need to include this. Which it has to be a render buffer, I guess. Render buffer storage. I always hated the API for creating depth buffers, but it has to be render buffer storage, and you don't do that with color attachments, I believe. You can just create regular textures and then you attach that to the frame buffer like this, but then the depth buffer needs render buffer storage. Let's Jesus. No, you do it. You also do it for. So when do you use this? Must be color renderable, depth, or stencil. But I don't ever see anyone use this for color targets, at least. So I don't think I used it in John. I don't think I did. Let me check. Source. This is my C++ engine, by the way. It's all over the place. Let's see. G buffer. I'm gonna make G buffer. Or pass. So that's, jeez, I'm gonna have to support all this shit. Fuck. Because if you want to do multi, like MRT, right, I'm gonna need to be able to support blends for a particular texture that's bound. Oh, it's so fun. Where do I actually initialize? Initialize frame buffers. New frame buffer. All right, let's go to that. So I do make render buffer storage for this. Let's see. Bind render buffer, GL render buffer, target render buffer storage, GL render buffer, width and height. That's interesting. Is that necessary though? Frame buffer texture 2D. Man. What is the difference between this and texture 2D? Some nice C++. What is the difference? Attach a texture image to a frame buffer object. So, I probably do this in my example then. Let me see. So bind. What is it like? Let me go to graphics. Set color attachment, bind color attachment. What the fuck do I call it? Bind uniform, set frame buffer attachment. Okay. GL frame buffer text ID, then I set the attachment for there. Okay, so I don't think we have to create buffer storage. What am I missing about that? Why do you create render buffer storage? What does that do? Do I have to do it? Target, internal format, width and height. I mean, I probably have to do it for depth. Although I didn't do it in InJon, so why not? So, okay. Setting a color attachment. We'll call frame buffer texture 2D with the, oh, that's the buffer. In-depth buffer. Generate textures. So that's just a texture. That's a text 2D, which that's probably wrong. Still depth component and depth component float. Okay. So generate our textures. I'm not 100% sure whether or not I need to generate render buffer storage. Frame buffer, render buffer. What does this do? Does this just generate? Does this do this? Attaches the render buffer specified by render buffer as one of the logical buffers currently bound on the FBO. You can attach it to the back buffer. Yeah, I don't know what the difference is. Why do I have to do that? Ahoy! Hey Dindy. Hey Dindy, I have an OpenGL question. Maybe you can help me. I hope my music's not too loud. I'm gonna get copyright strike again. I probably will. It probably already picked it up. Thanks, Susan. Hey Dindy, have you used frame buffers before? Because I'm reading through, I'm setting up color attachments. Do I have to do render buffer storage? Or can I just generate the texture and then just attach it with frame buffer texture 2D? Do you know? Because I'm reading through the docs and I don't see anything that says whether or not it's required. Hello, how did you get started on OpenGL? Where'd I start? LearnOpenGL.com. LearnOpenGL.com, and then look for this. On YouTube. Dude's got a good YouTube channel where he does like a SDL engine going over OpenGL and all that stuff. Check that out. Yeah, you need to set up storage, almost sure of it. Okay. Yeah, if you have some info on that, I'd appreciate it. It's just one of the areas I'm fuzzy on, I can't remember. See you, Zeffy. Thanks for dropping in. You do, yeah, Saeed says it. So yeah, I guess you do. So I'm not sure how this was working then, because this was working in John, but Benny Box. Yeah, Benny Box is good. It's Benny. Oh. And then if I ever get around to it, Victor, I'd like to do my own. Take the mantle away from Cherno. Be the top OpenGL series. That'd be awesome. Until someone much more qualified comes behind me and steals it. So draw buffer and read buffer, setting that to none. Yeah, I think Benny stopped doing it. I think, didn't he have a video where he said he's not going to do anymore? Or am I remembering wrong? I don't think he said viewport. Forget that. Width, height, text param. There we go. Confused about render buffer and frame buffer. I lost render scene to a render buffer object instead of rendering to a texture. Render buffer is simply a data storage object containing a single image of a renderable internal format. It's used to store OGL logical buffers that do not have a corresponding texture format, such as stencil and depth. Each buffer attached to a frame buffer can either be a render buffer or a texture. So our color textures don't have to have render buffer storage. In fact, when I was doing this in here, it looks like I was storing, or I was allocating memory twice for the color texture. So you don't do that. However, we do want to have, see this depth component, can you do for textures? Can you do that? OpenGL texture 2D. No, I just want, yes, this. No, that's GLSL. Oi, text image 2D is what I want. Internal format, isn't there a depth format? There's a stencil depth. So what are they talking about? Is this new? No, it's not. Each element is a single depth value. Each element is a pair of depth and stencil values. So what the hell? So are you using a render buffer? No, not currently. So what I'm reading here is that the render buffer is depth and stencil specific. You can do it for color, but you can just use a regular texture, which if that's the case, I'm just gonna use a regular texture. So you can provide other parameters for it. And then just create a color texture and you can attach it as a color attachment. But what I'm reading here is the, let's see, yeah. Render buffer allows for you to render to a render buffer object instead of rendering to a texture. Simply a data storage object containing a single image. So I'm wondering if there's memory considerations, but I really like the idea of being able to take any texture, apply it to a frame buffer, and then do shit with it. I like that, right? I don't want to have any kind of distinction between the two. So if you load in like a texture, say you load in an image, like a PNG image, and you load it into a texture object, into GPU memory, you should be able to attach that to a frame buffer and then like mess with it if you want. If you want to write stuff to it, I don't care. Render buffer is simply a data storage, contains a single image of renderable internal format. So I need to look and see if there's like memory consideration that I should be concerned about. If not, then I'm just going to make a texture. It's used to store logical buffers that don't have a corresponding texture format such as stencil and depth. Yet I'm seeing internal format, we have depth component, stencil index. So I'm wondering what this stuff means, unless it's talking about the type. But then the type would be like 32F, 16F, and then you give it the format of like stencil, right? Not sure. Let's see, can you step through the code and explain what you're trying to do? Yeah, sure. I'll give you the rundown. I'm not gonna give you the full spiel. Wait, this is wrong. Wrong one. Refactor, there we go. So, header only library, working on the graphics implementation. And I'm working on the render pass. So if we look at a render pass description, you have a frame buffer that you can attach. If you don't provide one, the default will be the back buffer. You have color attachments. These will be ignored if you don't have a frame buffer attached. And then we'll have a depth attachment. These I might just make it to where they're just all attachments. Because can you have, here's another question. Can you have multiple depth attachments? I don't think you can. I think you can have a single one, right? Can you write to OpenGL, write to multiple depth attachments? I don't think you can do that. I think you can have one stencil, one depth, and then multiple color attachments. Right? It's like GL, probably GL depth attachment. It's not named. Color attachment I, depth attachment. The attachment, this attachment point can only have images with depth formats bound to it. Stencil attachment, depth stencil attachment. And you should have a minimum of 8 color attachments available to you. The attached image becomes the depth buffer for the FBO, so it has to be one. You can only have one depth buffer. If no depth image is attached, depth testing is disabled. Stencil attachment, that becomes the stencil buffer. So yeah, you can only have that. So you have one stencil, one depth. So I should also have that as well. Right, so this is what this becomes. So you have a handle of graphics textures, which could be your color attachments, which I should call that. You have all your color attachments, the size of that array, and then you have depth and stencil attachment. Yeah, I don't think you can have more than one. You can only have one depth buffer. It doesn't make sense to have multiple depth buffers. You could probably upload custom. Actually, for deferred, you can write to multiple depth buffers. You probably had like color attachments you were writing to. You could do that. Right, so if you upload a bunch of color buffers that have like depth component, which maybe that's what that is, huh? Fun times. Multiple textures. Yeah, you can do multiple color attachments, yeah. For sure, but I think you can only do one stencil buffer attachment, one depth buffer attachment. It doesn't make sense to have multiple. I'm still kind of confused. I feel a little more in the know on what I should set up, but you can manually write the depth. Yeah. Render buffer attachment point. Frame buffer attachment. Let's look at home slice here, because he sets render buffer storage, so he doesn't make a texture. He just does render buffer storage. It's fine. For the depth buffer, he does render buffer storage. So maybe that's what we do. And then we'll do render buffer storage for like a GL stencil component. And then GL frame buffer, render buffer, GL frame buffer, depth render buffer, depth render buffer. Maybe this is what we should do. So if you have, if you declare a depth texture, oh shit, what does that look like? No, not Visual Studio. I do not want Visual Studio. Garbage. You create oh. Extra format types. This is really only the formats that I have right now. I could do depth 16F. The only problem with this is this creates like actual textures, because that's what that would go into, unless I looked in like the implementation. No. Texture create, and look in here, and then depending on the format provided, I create like a render buffer storage, and then store that instead. Maybe that's what I do. See, this one just sets up a depth texture. So bind texture, GL text 2D, setting up all that, depth component. Drawing to an FBO with an RGBA8 internal format and a depth 32 format works for both linears. Okay. We must return to monkey. Return to monk. What have you missed? Hey Vefo. You've missed everything. Header only library. So I'm converting, or I've been converting over the past week, Gunslinger to a header-only library, so you don't have to compile it anymore. Just include it in your project, define the GS implementation, and then you're good to go, which is what this is here. This is like a little example I'm doing to just test stuff as I'm going. So that's changed. The implementation for the interfaces has gotten simpler. So the platform interface is just this now. It used to be full of function pointers. That's gone now. It's just all of this, and then all of the API stuff is taken out. And now it's just external functions that you can define in your custom implementation if you want, or just use the default one, which uses GLFW under the hood. Graphics works the same way, audio works the same way, and then right now I'm working on the graphics implementation. I didn't convert over what I had before. I've instead moved to an explicit pipeline, so it's more Vulkan-like, and then it takes that takes those Vulkan concepts and it boils it down to an implicit pipeline for something like Opengl. So I'm working on the Opengl implementation using the explicit pipeline for Gunslinger. And specifically right now, so I just did some pipeline stuff like blend state and finished all that up. Right now I'm doing render passes, so frame buffer attachments and all that kind of stuff. That is pretty much it in a gist. Caught you up. Alrighty. Okay. So looking back at what Home Slice was saying here, drawing depth texture bound to an FBO. Texture 2D with the depth component. Yeah, so he just does. All right, don't you plan to create an audio system? It's already in there. I already have an audio implementation. So, audio I, so this is the, oh, what did I say? That's not it. Audio. Here's the audio interface. So, it has a slot array of internal audio sources, so that's raw data. All the instances for that, max audio volume, so all this stuff that gets defined. An audio source is a collection of raw audio samples, channels for that, sample rate, sample count, and then an instance just points to a source, and then it has instance data for that particular thing. And then here's the API for the audio. It's fairly straightforward, pretty simple. All the init, create, shut down, all that stuff. Loading an audio source from file. I'll probably get rid of this and put this more in a util. Not sure. Or maybe I'll keep it, I don't know. Creating an audio instance, and then various play and get data and all that kind of stuff. So yeah, it's working. So actually I can show you how to use that real quick. So what is it? Audio source. Let me create this, make this easier. Audio source, let's just call it a source. Man, I really don't know how to do these names. This has bugged me so much. GSA source, should I just call it that? GSA instance decal. Let's just do that. I've had so many people that have said that the names are too long. So I'm trying to provide in the framework, if you don't define this, so GS no short name, then I'm trying to come up with really simplified short names for a lot of this more explicit, longer named stuff, just so it's kind of easier for people to use. I just don't like the way any of this looks, so I'm not happy with it yet. But if we want to load like an audio file, I think I have an audio file in here. Yeah. So a source equals GS. What is it? Audio load from file. GSA. Yeah, GSA load. There you go. Assets cold morning text.mp3. And then there's a couple ways you can use this. You could just play directly, which I think is just play source. Do I have that? If you just call play source, then what it does is it creates an instance in the background, and you give it like a, yeah. It just creates an instance in the background, throws it into thread, and starts playing it. So actually, if I load that up, I didn't mess this up. Oh, boy. Graphics implementation. We're at 713. What's the problem? Oh, right. So loads that source and it just starts playing it. And then there are, you could do that, or you could cache the instance. So you could make a, let's see. So this instance decal, so we actually need an instance declaration. Dot source is a source. That's really all I need, because persistence is going to be defined to 0, and then we could do GS audio play, and then you actually pass up the instance that you want to play. So you create an instance, GSA make instance with the decal, make instance, create audio instance, I should rename this. This should be a pointer. Let's go to the audio implementation. Create slaughter rate instances decal. Main 220. What's the problem? What's the problem? Audio implementation. Oh, yeah. should work. So actually, I could just do this. Boom. Just say make instance is not this, it's instance create now. Okay, so now it should work. Beautiful. Okay, and then as we're going, so the difference between this is that we've actually cached the instance, which gives us a handle to that instance. As we're going through here, we could do certain things, right? So if GS platform key pressed, then what we'll do is that correct? GSA is playing. God damn it. GSA or GS audio play. Okay, so just put those in there. So if we're playing, if the instance is playing, then GSA pause the instance, otherwise we'll play the instance again. All right. GSA is playing. Oh, that's right, it's just this. So we're going along. If I hit P, we pause the audio. Oh, that's right. I forgot. Make it persistent. It needs to be a persistent source or instance, or it's going to get deleted. But that's kind of confusing. I might change that. Yeah, but there you go. So that's how to load audio, create an instance of it, and then start playing it. Hey Christian, what will this engine do? Just graphics? No. So it'll have, this is more like a low-level framework. So it's a header-only framework for platform, audio, graphics, and the graphics implementation will be. It'll have backends for Vulkan, DX12, Metal is planned, OpenGL so that I can do Android and Raspberry Pi, and then I'd like to do a software renderer as well. So if you had something that didn't have hardware acceleration, you could use the software renderer. Do you use standard MSVC? Right now, I'm compiling with that, but I have for this example, I have implementations for Linux with GCC, OS X with GCC, MinGW, and then MSVC on Windows. All right, let's get my music back. And I don't want to play this. Yeah, the only downside is loading up audio, loading up raw audio in debug takes a while. but it's not that different. All right. Anyway, back to render passes. Let me turn this down pretty low. Okay. So for the render pass, right now I'm just using a default render pass. So no color attachments, no depth attachments, no stencil. There's no frame buffer, right? It's just the back buffer. Would you define that by just submitting an empty default render pass? But what we're gonna do is start working on attachments. So what I'm gonna need to have is when you're creating a texture, I don't want to have like a texture type. I think I just want texture formats. Format type, you do like depth 32F, right? So like what's the Opengl. Let me get my music back. Yes, keep playing Evanescence. Ooh, girl. All right, image format. What is this? Textures and render buffers. Color depth, depth and stencil. Yes, ma'am. That's compressed formats. Depth component. Okay, so we'll do depth 16, 24, or 32F. I'm assuming that 16 means it's a floating bit, or a float format. It's not a 16 unsigned bit format. Let me look. Because I'm going to be more specific with it. Each element is a single floating point value, multiplies by depth scale and depth bias. Okay. So this might be wrong. I'm calling it depth 32, 16, and what was the other one? It's not 8, was it? What was it? 24? Depth component 16, 24, 32. What is just depth component? So it's just 8-bit, or yeah. pretty sure that's correct. Although you can't have an 8-bit float. That doesn't make sense. Should I do this? But then that kind of ruins the designation that I have going on here, where this is explicitly HDR textures, right? So floating bit or floating format. Same thing with this, and these are unsigned byte because they're 8 bits for the channel. You're coding crypto OpenSSL. That sounds fun. All right, bro. So you pass in a depth format. We're going to create a texture. All right. So what is this API going to look like? So dot depth equals depth texture. Oh, that's an no. So you make a render pass. With a render pass description. And then that will set depth, stencil, color, and then the FBO. So these are the things you'd have to fill out, right? So our color would be like a thing of handles. GS graphics texture T. That's a pointer. No, it's not. So just color attachments. And we'd fill this out with whatever attachments we wanted, right? So like RT0, RT1. You know, up to however many render attachments we're gonna have for multi-pass render. So then we would set the attachments, color attachments, size of color attachments, and if we have a depth texture, we have a stencil texture, and then if we have an FBO. So this would create a full render pass. And in that render pass, whenever you begin it, it's going to bind this FBO, it's going to bind all the color attachments, it's going to bind the depth texture attachment, stencil attachment, and that's all, folks. So we got to implement all this now. Alrighty. Okay. So when creating a color attachment, or a depth attachment, or a stencil, so let's look at the stencil formats. There might not, this might be something where we do if you do stencil, it looks like you're going to be doing let's see. It's a header only framework, so not a single header. And that's just because the implementations are too big. So if I put it in a single header, I mean, you could do it. If I do it though, it won't show up in GitHub. Like you can't look at the source in GitHub, so that's a pain in the ass. And also just loading up the individual files in a text editor would take a while. So that's the only reason it's split up into multiple files. But the end result's the same. I need depth masks. Oh, I set up depth masks. I do that. Never mind. I think what I should do, what might be a good idea just to make sure that I have everything, is just go through this open.gl stuff and learn OpenGL tutorials and just make sure that I can do all these using Gunslinger. That'd probably be a good idea. So let's actually look at that. That's a good idea. Glad I thought of it. So getting started. We can create a window. We can create a triangle. We can create shaders. And we can do index buffers, all this stuff. We can't set polygon mode. Maybe that's something we should do. Might be a good idea. Are we learning how to make a triangle today? Can't wait to see. We can do that. Are there going to be default shaders, or do you need to write shaders every time? There's going to be a util library written on top of the core framework that you can include that'll have a lot of default stuff. So it's going to have immediate mode drawing and all that kind of stuff. So if you just want some like simple drawing stuff, then you can include that util library and go to town. Like draw a triangle, draw a textured rect, you know, push and pop matrices, all that kind of stuff. But if you want to write your own stuff, you can do it. People use utils to create single file only libs when regular development occurs on multiple files. Saying, don't know if it's a good idea. I might do that. I don't know. Maybe just something that copies and pastes everything into like a simple, like a standalone GS header only .h or something like that. Maybe. But right now it's pretty simple, right? Just include this folder in your project, and then define this, and then include the header file, the main header file. It's really nothing more to it. Simulating immediate mode rendering, how would that work? Kind of tricky. Well, not really. It's just you have to pull up vertex information. So as the user is doing like submitting individual vertices in order to draw something, you put that into a buffer that you're accumulating, and then whenever any significant state changes, you push that buffer out to the GPU. Significant state changes being like you bind a new texture, you change any pipeline state, you change any render path state. I could go through this. I don't want to do this right now, and do this. All this works. So let's go to the point where I know it's not working, and let's start there. So shaders, textures, transforms, camera. We should be able to do all of this. Every single bit of this should be currently supported, because he ends with camera transformations. So we could do this. Yep, this is all supported. I really want to get to, let's get to where he starts doing, not lighting, I want to do, yeah, frame buffers. So we can already generate frame buffers right now. That's not an issue. Good. Fantastic. So let's see. So we're going to generate a texture attachment. The main difference here is that we set the dimensions equal to the screen size, although not required. And we pass null as the texture's data parameter. Yeah, so I don't care about having to do that. If you want to have a texture that's a different size from the screen, do that. You don't need a full-size texture. That is up to you to decide. And then I'll have callbacks so that you can resize your textures when the window changes. So you can do that. Frame buffer texture 2D. Depth stencil. So that's if you want to stencil. So depth 24, stencil 8. To attach both depth and stencil as a single texture. Okay. Shit. Texture image render buffer object is actually a buffer of bytes. However, cannot be, you can't directly read from a render buffer object. This gives the added advantage that OGL can do memory optimizations. Okay. Well, I might want to do that then. Because their data is native, they're quite fast when rendering or writing data or copying data to other buffers. For stencil 8. So I probably want to support this, and that would be because you can't have a stencil buffer without depth. It doesn't make sense. It has nothing to compare to. So let's go back to here. See what other formats are there. (16 bits, 24 bits. That's an F32. I32, UI32. 32, 24 bits for this. (16, 32, 32F8). And then just stencil. Stencil index 8, which I'll just call stencil 8. YOLO. Okay. And I think for what we'll do is we'll say, oh man, I don't want to do that. I mean, we could force it. So I think if you do this, we'll force a render storage buffer. same. And then for the texture descriptor, we'll do like man, do I want to say is render target? I don't necessarily like that. But whatever, we'll do it. It's killing me. I'm kind of getting tired of the evanescence. All right, let's keep going. Got a good pace going here. I'm really not a fan of this. I'd like it to be more implicit than explicit, but whatever. So let's go to graphics implementation. So when we're creating our texture format, we need to decide if we're using render storage buffer or not, right? So if we're doing a text image 2D or if we're doing a render target. Or, because I don't think you can do, create render buffer storage. Otherwise, we go in here and we just create a normal texture. I think that's the way we'll do it. Maybe. Not sure. So is render target? Yeah. All right, we'll just do this. I might not like this in the future, but for now, fuck it. So let's switch on these. Let's switch on all these. Damn it. Tell you what, we're not. For now, I'm not doing it. I'm not going to worry about the performance just yet. we're gonna do this. So if our format is any of these, then we're gonna do that. Otherwise, we're just gonna do a regular texture. That's what we're doing. Why? Because it makes it easier. I will worry about the other stuff in the future. Okay. All right. Do that. Okay, so render buffer storage. Let's just look at something that uses it. So generate a render buffer. Oh, it already generated a texture. Fuck. Okay. So we'll do this up here. Frame buffer, render buffer. So what does that do? And also the size. Render buffer storage. So now in here we switch on this. All right, so bind the render buffer. Jeez. And then we'll do that down here too. Just okay. Where do you specify GL depth component? I'm pretty sure this is where you see. How the fuck do you do this? Internal format, base format. Is there a depth stencil attachment? What do you actually create, bro? You don't. depth stencil attachment is what you need. And then the component is GL, what is it? GL depth 24 stencil 8. Is that even right? There's no just normal depth component. Man, this is depth 24 stencil 8. I mean, that's got to be it, right? Let me go in here. I don't necessarily know this is right. So let me look. Oh, you still wait. Okay, so there's a depth stencil attachment, render buffer storage. You don't have to do this. You could just do this. GL depth stencil. You know what? That's what we doing, boys. That's what we doing. So it's just text image TD. And then I'll write a note that says, be more performant. So what I'll probably do is make, if you do this, so this is the format that I want. If you do this, then you can designate whether or not you want it to be specifically a render target. Then it'll create render buffer storage for you in the back. Otherwise, it's going to do this. That's the point. So 24.8, 24.8. Width, height, do we want data? Sure. You can pass up data, I guess. Okay. I feel better about this. All right. Thank you, Opengl, for being at least somewhat sensible. Okay. Case. Already got this guy. Drop him down here. Is there a depth 8? Is it just depth component? Stencil attachment. Oh, it's right here. So what is depth component 24? Is that actually what I want? How do I create like a depth texture? Oh man. I want a depth texture. I don't know about this. What's up, VMA? Came late, probably. Yeah, a little bit. Frame buffer, texture 2D. Yeah, I'll do that in a second. Stencil attachment. I really want to get some better. Let's see. GL text image 2D. So stencil index, depth component, GL stencil. That's for the format, right? So if we're doing this for depth, then the internal format is GL depth component. So depth 8. Each element is a single depth value, and it converts it to a floating point value. So if I have creating a depth texture for the frame buffer, yeah, I'm just setting this up for the render pass. Oh. Just part of the graphics implementation for the user to be able to create render passes. So creating attachment textures for color, depth, and stencil. But I'm a little confused on the base and internal formats that's required for this if you're setting them up as readable textures. I don't know what to put here. And I'm trying to find any kind of documentation. So the internal format, what would the internal format for this be? Must be one of the base internal formats, one of the sized in table 2 or one of the compressed in table 3. Okay, so table 1 or 2. So it could be an internal format of depth component, or it could be a sized internal format, which these are all, or compressed. Depth component 32. So you can't, there is a sized 32. Well, Jesus, I wish they would update their documentation here, because there's no 32-bit. Is there a depth component 8? Does that exist? Because if not, I'll just get rid of this. Like, does that exist? With the DL component, you know, it's float data, null. Or like 16-bit, or is it all? Because there's a format, there's, or is it just for the stencil that you can do that? Actually, I don't know. Right, because if these don't actually exist, then I'll drop them and get rid of it. But if there's a 8-bit depth component and a 16 and a 30 or a 24 and a 32F, then I'll do that. Same thing for this, right? So this stencil, so what would the 32F stencil 8 format be? Is there a 32F8? $32 doesn't require the F. All right, here we go. So depth component 16, 24, or 32F. But I don't think stencil is. Can you do stencil in a texture? Do you know that, VMA? Does it have to be rendered buffer storage, or can you actually do it in just a regular texture? It would be sweet as shit if I could just do it in a regular texture, so I don't have to worry about splitting this up just yet. 24, 32. So that's internal format. Which is format, internal format. So 16, is it, I think it's just depth component 8, or just depth component. It's not DL depth component, so that's understood to be 8 bits. Valid operation if format is depth component and internal format is not depth component, which that is there. And it's texture 2D. That's good. All right, so those are fine. I bet you can do stencil with regular texture. I know you can do depth stencil, but can you just do stencil? Yeah, there's a... Oh, here we go. So GL stencil index may be used as a format only if 4.4 or higher. So this will not work for me. Oh, shit. So if I have these, I'm gonna have to make render buffer storage. Yeah, but what's the, is that requiring 4.4 and above? Which I can do on Windows, but I can't do it on Mac then. Yeah, so I'm supporting 4.1 for Mac, which sucks, but I need to do it. Otherwise I have to nuke my Mac support. No, I don't want to do that. Not yet, anyway. So what I might do is instead make depth stencil be something you can do, because I think that's... You won't be able to read back from stencil if it's a render buffer. Yeah, no, you'd have to copy it over to a texture. Yep, you'd have to do a manual copy. That is annoying. Yeah, it's just stencil buffer shit. Well, Mac strikes again. Only available post 4.3. I know. Fucking Mac, man. Like, at least get me to 4.3. You shit OS. It's interesting. So many ways to do the same thing. It's just confusing. Mac doesn't support... Mac's OpenGL support is capped at 4.1 for reasons. So you do text storage 2D for an RGB A8 image. That's texture. So bind texture, texture, bind texture, texture depth stencil. You could do depth 24, stencil 8. But I think storage 2D, so I think even that's a later thing. That's not even, yeah. So that's a 4.2. I'd rather use Vulkan everywhere. Yep, exactly. Only if GL is 4.4 or higher. Okay. Well, I need to support some kind of texture buffer. So this is not supported. At least not for now. Apple has always been a problem. Yes, absolutely. Again, the only issue is that I use this framework to do work stuff. I use it to make tools, so I can't drop support. I need to consider that. So what I'll probably do is have like the ability to query features, and then I'll just split off based on that. That's the ugly thing about doing these types of frameworks, is that you have to split features off, and this is gross. So I got to figure out a good way to do it, because the last thing I want to do is do something like if defined GS platform Apple, right? I do not want to start dropping shit like that everywhere in my framework. So I'll think of a good way to figure that out. All right, so I can't do this. Hell, is depth stencil even supported? I don't even think depth stencil is supported. I might have to drop those over to render buffer. I heard for metal you have to use Objective-C. Is that true? I'm fairly certain, which is another retarded element. The depth is interpreted as depth component. Stencil component is interpreted as specified the depth stencil format. Where's the depth stencil internal format? So what is this? 32F, stencil 8, format as step stencil, type is this ridiculous thing. What is the REB? Christ. Yeah, I mean, there's a good chance I won't support metal. there's a real good chance, at least no time soon, and it might just be out of protest, just because 32 stencil 8's not a thing, because it's 32F. Yeah, just out of protest of I don't want to support Apple any more than I have to. What would it be, 4.1? There. All right. Well, I'll have to do that in the future. For now, you can't read back. I mean, it would probably have to be something like this. It would be like case format stencil 8, right? And then I would do whatever as text image, if and only if, like not, if not defined, GS platform Apple. But I can't stand specific stuff like this though. No, Apple doesn't support Vulkan. No, they don't. They support like a very small subset of it, if anything. Or people have written something, I can't remember, but no, they don't. They want you to use metal. They want proprietary stuff, and that's it. Which, good luck. Yeah, Molten VK. Yeah, exactly. It's something like that. Something stupid. I want them to go under as a company. So I'd have to do something like this. It's like if you don't have Apple, which I should just rename this. To like there. If you're not at platform shit company, then we can do normal stuff. Do cool stuff. Otherwise, yeah. All right. Welp. Because what are the advantages of header only? You don't have to build a library, you just include it. So drop it in your project, give this pound define, include the main header, and then you're good to go. That's it. That's all you have to do. You don't have to build it as a shared library or any of that stuff. What time is it? I might end the stream here pretty soon. Why use nuclear when you can use electron? No, thank you. Okay, so we have the ability to be able to create render textures. All right, so now that we've done that, we can create a new texture. Let's just create a render texture. RT0. Alrighty, and then let's create that guy. Graphics texture, or width, let's do let's make it the screen width and height. I don't know if I have functions for that. Window size. Wait, what? Oh, set. Okay. Okay, so we can get window height. I'll just make it that. Let's make an RGB8 data. Give it null because we're going to render to it. Window platform width. Okay. And then we need to create a render pass. So the color attachment is just going to be this guy. We're going to need an FBO. fucker. Yes, it is. GSGL render past T. Color, depth, stencil. Oh, where'd we crash? I don't know, I'll figure that out. Was platform window width and height when you already have window size, redundancy. So you can have multiple ways to do the same thing. It's a good indicator of a library that's doing something useful. So if I just have like the default window size function would be something like this, and you give it the handle to your window, right? GSFAC 2. Well, in this instance, I don't want that. I want a width, right? I just want a U32. So just give me that. Don't pass it back to me like this. If I were to do something, if I just kept that as the only way to get that, then you would have this as window size, and then I would have to come down here and do ws.x, ws.y, right? So it's just more for me to do. So I provide a way, I want a way to be able to just get that window width, and that's the only, I just want that. Does that make sense? So good API design has redundancy built into it so that you can have multiple ways to do the same thing, depending on what you want, what the user wants. So this is good, but we're crashing somewhere. So let's figure out where. Probably something dumb. Oh. Oh, god damn it. We'll do this for now. So it's just crashing somewhere in the call stack. So that's fantastic. So let's put I'm gonna have to go here in a second and go get some lunch. But let's try to see, let's see. Let's just call that. Graphics shutdown, I'm sure it's somewhere in here. Did the platform shut down? Is that where it's dying? Platform? So in GLFW terminate, it's dying. That's fun. Why? Huh. I mean, if I actually comment this out, what does it do? Is it fine? Okay. Unreal. All right. Why you die? Am I terminating? So should I free all windows? That's probably why I'm not. So there must be somewhere. Platform destroy. Oh yeah, because I call free after the fact, and then in here, I destroy all the windows. Right? Platform destroy. Do I even have? What? Do I even use that? Slot array free all platform windows. Oi. Yeah, it's right here. Where are you? CFG free window. Destroy window? Yeah, there we go. Alright, so we need to go through iterate through here, grab the actual pointer to the window. What's my macro? Oh. I can't do this here. Do this here. What is this macro? GLFW window handle. Should be alright, just past the window. Yep. Hey, rare MC. 502, you're not happy with this. Slot array gets. Oh, fuck off. How do I do this? Yeah, I should just be able to, okay, that's right. No, platform, iterator. Yeah. Still crashing. Fuck you. It's in that terminate. Why in that terminate? What have I done? Why would destroy window being... Alright, this is being stupid. This is being absolutely stupid. Tell you what. Go in that order. Okay. It's in the OpenGL driver somewhere, so that's not going to help. Yeah, there's something with terminating. I'm going to have to figure this out later. Can't do this, can't do this. So let's write a note. Not that big a deal because all it's doing is just releasing memory back to the OS. Not a big deal. So okay. So we're creating our render pass with our FBO. Are we creating the FBO? We sure aren't. Yeah, we are. Okay. Creating the FBO, creating the render pass with color attachments. So now we need to bind. So we bind our render pass, right? So RP is this. We bind the render pass with the actions to clear. We're clearing everything. So let's go to graphics. Begin render pass. Okay, so we're just passing back render pass handle, pass back the actions. GLFW terminate is meant to destroy all windows. Yeah, but just calling destroy window itself was dying, so I'm not sure what's going on. And it was acting fine before, so most likely with stuff like this, it's not what you think it is. There's somewhere else in memory that's being affected, and it's just touching it in a weird way. Right? It's probably working just fine. I've probably done something with memory somewhere else that's messing it up, and I've got to go find that. And if I remember what I've been doing recently, it's like creating render targets and frame buffers. So there's probably something strange with that. That's probably it. So we need to bind the frame buffer. And then when we end the pass, so I have that in I need to make this. This is going to set all our state back to default. And all we do is just push an empty command into here, and then we go to submit command buffer. Unbind the frame buffer. That's pretty much all we have to do. Maybe reset. Probably do that as well. So like just unbind everything. That might be what we do. Pretty sure that's the correct answer. So then here you would draw. All right, and then here's a full render pass, what it would look like. So you render your entire scene with here, begin the render pass, bind the pipeline, bind all the bindings, draw, and then you end that pass, and then you do the final submission. Why do some people think C is obsolete? Because of years of abstraction, and I don't know. Alright, we gotta buy the frame buffer. But the frame buffer, you gotta check if the frame buffer is valid. Oh, we gotta check if the render pass is valid. So if RPID, so I default the slot array handles to 0 to mean that they're not valid. OGL render passes, and we will give you a warning. Timed action, warning, OpenGL. Oh yeah. Again, render pass. RPID. Otherwise, oh, I shouldn't continue because that's just a default. No, this isn't what I want. We'll just do a default render pass. That's not what I want to do. So if RPID then we'll bind frame buffer and attachments. Okay. Yeah, people don't like dealing with memory. That's pretty much it. All right. RPID and slot array exists. OGL render passes. All right, we're gonna bind the frame buffer. So let me get the code for that. Bind frame buffer. Target and frame buffer. What's our target? Draw frame buffer, read by. Okay, so what is just GL frame buffer? Let's just default to draw, right? Oh, frame buffer binds frame buffer to both read and draw frame buffer targets. All right, for now we'll just do this, and I'll make a note because we do want to support the ability to read and write, obviously. Okay, so bind frame buffer, GL frame buffer, and our target, which we actually need to check to make sure that the frame buffer exists. So get the render pass from our slot array. So GSGL render pass RP is GS slot array get our pointer to render passes RPID. If RP FBO and frame buffers RP FBO. Actually, this is a handle, so it need the ID. Okay, now we can bind frame buffer since it actually exists. All right, and then the uint is GS slot array get all right. RIPD. Now it shouldn't see anything. Yeah, so we got a blank screen. All right, so that's how I know the frame buffer is being bound. Okay. So we're actually writing to a frame buffer. So now we need to do color attachments. And the render pass so for this, we bound the render target. Now we got to go through all these color attachments, make sure that they're valid. All right. GS for range, GS dyno array size of the color. Okay. So the color is a handle. So if CID and okay, so if this color ID exists, then we're going to grab texture T, just call it render target, slot array get, and this is an order, so yeah, so what we're gonna do so this guy. Color attachment 0 plus I. Okay. And what's the frame buffer attachment. So the level, what does the level specify? The bitmap level. Fantastic. So I'm going to provide that as well. For now, we're just doing this. Frame buffer texture, frame buffer, color attachment 0 at I. And it's not render texture, it is RT. It's not I, because it's just a 4 range. I'm actually going to need a 4 range J. Now let's do our own. Okay, so now we should be rendering out to that, and then we bind. We bind all of our textures, and then we're doing clears and render pass. So this is all rendering to a texture. Now I need a full screen quad, and then I can render the scene. But I'm gonna have to do that later. I'm actually gonna have to go. Man, I appreciate you guys showing up. Good combos. Thanks for watching. I'll stick around for like 5 minutes if you guys have any questions. Otherwise, I'm gonna have to head out. But again, if you're just joining, like, subscribe, join the Discord. There's all that stuff in the description. I'm writing a header-only game framework in C99 specifically. It's going to have backends for Vulkan, DX12, maybe Metal, depending on how much I want to deal with Mac, OpenGL, ES. It's going to target Android, Mac, Linux, Windows, and it'll have ways to be able to provide specific implementations for platforms, graphics, audio, etc. And I'll show how to do that. So the plan for this is to finish up this header-only issue that I have, or header-only implementation of this framework, and then do a video covering it, kind of show it off, and then do like a couple of small examples. I'm thinking Pong would be good, but like fun Pong with post-processing and all that kind of stuff. And then probably announce a game jam for people to kind of dig in and mess with it if they want to. So where'd you go to school? I went to University of Texas at Arlington, and yeah, I got a CS degree. Although it wasn't that useful. All right. I will talk to you guys later. Thanks for showing up.